Module 6, Lesson 14, Summarizing a Distribution Using a Box Plot. There's lots of fun lessons in Module 6 as we do a little bit less computation and just a lot more looking at data. Box plots are fun. Lots of people have never seen them or heard of them, so if you go to your parents and ask about box plots, they might be saying, I have no idea what you're talking about. But you are going to learn how to construct a box plot from a given set of data. We'll be looking at steps 3 and 4 dealing with statistics. We are going to summarize the data with graphs and numerical summaries. A box plot is a type of graph. And we are also going to be answering questions using a box plot. And that is step 4, answer the question posed in step 1 using the data and the summaries. What is a box plot? A box plot is a graph that is used to summarize a data distribution. Some questions to think about in this lesson. What does the box plot tell us about the data distribution? So we look at this graph, and what are some things we can instantly know by looking at the graph? And how does the box plot indicate the variability of the data distribution? How can looking at the box plot tell us something about variability? Example number 1. Consider the statistical question, what is the typical amount of time it takes for a person in your class to get to school? The amount of time it takes to get to school in the morning varies for the students in your class. Take a minute to answer the following questions. Your class will use this information to create a dot plot. Now I've modified this part of the lesson because we're obviously not together as a class. So if we were in class, you'd write your name and an estimate of the number of minutes it took you to get to school on a sticky note. What were some of the things you had to think about when you made your estimate? You probably thought about how long does it take to get from the front door to the car, or how long does it take to get from the front door to the corner and from the corner to the school. So you think through the process of getting to school, thinking about how long each of those steps takes. So here are some made-up answers from our class. So I created an imaginary data set. Quick review. Use the made-up data from our class to make a dot plot. Dot plots / line plots and box plots go together. So take a moment, pause the video, and create a dot plot. All right, so here is a dot plot of the data that we collected for the number of minutes to get to school. And you can see my dot plot is constructed of a number line. And I started at 5 because that was my minimum value, and I numbered to 11 because that was my maximum value. Each one of these dots represents one person's answer. So we've got 1 5, 2 6s, 1 2 3 4 7s, 3 8s, 2 9s, 10, and we've got 3 11s. So just a very simple dot plot. Now interpreting the dot plot, what does each dot on the plot represent? Pause, think about it for a second. You should be like, ooh, I know this one. Each dot on a dot plot represents one value in a set of data. So each of these dots represents one person's answer to the question, how long did it take you to get to school today? So taking a look at our dot plot, what is an estimate of the median time to get to school? And remember, median is the middle. What is the middle time? And think about this question. Does the median do a good job of describing a typical time that it takes students in your class to get to school? And you'd pause, you'd think about this for a second. Well, as I looked at this data set, I thought to myself, the median's kind of around 8. I've got about half the answers over here. I've got about half the answers over here. I mean, I could get really picky and say maybe it's 8 or 7, but 8 looked kind of like a middle point for me. And I felt like it did a pretty good job describing a typical time it takes a student in our class to get to school. Looking at the dot plot, what are the minimum and maximum times? The least amount of time it takes a student to get to school and a maximum amount of time. The minimum time is 5 minutes. The maximum time is 11 minutes. So we've come up with a rough idea of the median. I roughly said that was 8. I said that the minimum was 5, and I said that the maximum was 11. So taking a look at some exercises here, here is a dot plot of the estimates of the times it took students in Mr. S's class to get to school one morning. So put a line on the dot plot that you think separates the times into two groups. One group representing the longer times and the other group representing the shorter times. And you can see that I picked someplace kind of between 10 and 15, probably about a 13-ish is what I picked. And remember, this is just kind of an estimate here. No right or wrong. I felt like I had about half of the responses here, and I had about half the responses here. So now we're going to add another line on the dot plot, and that's going to separate out the times for students who live really close to the school. Now stop and think about this for a second. Which set of students live really close to the school? Would that be these students, or would that be these students? The students who don't take very long to get to school, or the students who take a lot longer to get to school? Well, I would hope that you'd be saying that the less amount of time is going to be for the students who live closer to the school, and that this greater amount of time would be students who live farther away from the school. So here is where I would add my lines. I took a look here at this lower section of data and I said, where's about the middle of that section? And I felt like it kind of came in at this, probably 8 is about where that's at. And I looked at the other side and came up with about 25, about half here, about half here, got about a half here and half here. So I've got 4 about equal size sections of my data. And what I did is I first cut it in half, so I had 2 equal size pieces. Then I cut each of my equal size pieces in half. And that should sound somewhat familiar from yesterday's math lesson, lesson 13. So our dot plot should now be divided into 4 sections. Record the number of values in each of the 4 sections. How many do I have in each spot? Well, I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5. So I've got 4 pretty equal-sized groups here. Now you might have divided yours a little differently. That's okay. What we're doing is we're taking a look at the dot plot and trying to see how we could divide it up. Now, if we were in class, we would share with each other our dot plots and we talk about things that we did the same and we talk about things that we did differently. So I'd like you to think about my dot plot. What did I do differently from you? We probably are going to find that we'd have a variety of dot plots. They wouldn't all look the same. There might be some similarities, but they're not going to be exactly the same. Question: can you think of a way to divide the data set into 4 parts so that everyone would divide it up in the same way? Is there a way to do this so that everyone's dot plot would look the same, or their groups from the dot plot would look the same? If we were to use what we learned in the last two lessons about the median and quartiles, we would each divide a data set into 4 parts with about the same number of data values in each part. So if we were to take our data set and find the median, and then find the upper quartile and the lower quartile, if we all followed the same procedure there, we would all have data sets that would be divided up the same way. So here we have the times in minutes for students in Mr. S's class. They've been put in order from smallest to largest, and the question is, what is the median time to get to school for students in Mr. S's class? So now, instead of kind of looking at the dot plot and guessing, we're actually going to go through a mathematical process to divide our data into 4 sections. And the first thing we need to do is find the median. So pause the video, pull out your workbook, find the median. And when you're done finding the median, you're going to find out that the median is 15. Now it says that there are 27 times. I've got 27 students who responded here. That's an odd number. An odd number means there is a number on this list that is going to be the median. I can find it by taking away the number that is the median. I'm left with 26 numbers that are not the median. And if I divide those in 2, I find out I've got 13 numbers that will be before the median. Then there will be the median and 13 numbers after. So I can split this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here's the median, and I've got 13 that come after. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I've now found the median of the data set. So what is the value of the lower quartile and the value of the upper quartile? Now remember, for quartiles, we look at the numbers that are lower than the median, and we look at the numbers that are above the median. The median of this lower set is quartile 1, and the median of the upper set is quartile 3. So I've got 13 numbers here, which means, because it's an odd number, that the median is going to be one of the numbers. So I'll take the median away, and I'll be left with 12 numbers. I divide it by 2, and I find that I have 6. 6 that will be before quartile 1, and 6 that will be after quartile 1. 1, 2, 3, 4, 5, 6. There's my median. 1, 2, 3, 4, 5, 6. So right here is my quartile 1 at 8. Here is the median of my data set at 15. And I can come over to the upper side, and I can find the upper quartile, and it's also 6, 1, and 6. 1, 2, 3, 4, 5, 6. Quartile 3. 1, 2, 3, 4, 5, 6. So I have a lower quartile of 8 and an upper quartile of 25. So I've got 8, I've got my 25. So now I have found 3 numbers to help describe my data set. I have the median, I have quartile 1, and I have quartile 3. The lines on the dot plot below indicate the location of the median, the lower quartile, and the upper quartile. These lines divide the data set into 4 parts, about what fraction of the data values are in each part, about how much of the data is here, about how much is here, about how much is here, and about how much is here. And this is a little tricky because, of course, my lines run right through some of my data points. So this middle section looks like it doesn't have very much in there, but remember, we're only using one of these 15s. The rest of them are coming in here. We're using only one of the 25s. The rest of them are coming in here. So what we would find is that each of our areas has about 1/4 of the data. We've got about 1/4 of the data values in each part. So making a box plot. The goal, the mission, the objective for this lesson. To make a box plot, we first need to find the minimum, quartile 1, the median, quartile 3, and the maximum. We use all 5 of those numbers to make a box plot. And sometimes this is referred to as a 5-number summary. So the first thing we want to do is we want to draw a line where the median is. It's at 15. The next thing we want to do is go to quartile 1, 8, and draw a line for quartile 1. Then we want to go out to quartile 3 and draw a line. And now we're going to connect this together to make a box. So we've got quartile 1, the median, and quartile 3. So we've used 3 of our 5 numbers. Now what we do is we go out to our minimum, and we're going to put a little dot there and draw a line back in and connect it to the box. And we're going to go out to our maximum, 60, and draw a little dot and draw a line out to it. And now we have what is known as a box plot. So box plot, but it's also been called a box and whisker plot, because we have the box in the middle, and then we have the whiskers that go clear out off the side. So we have a box plot or a box and whisker plot. Kind of fun. All right, so here we have another set of data, and we're going to practice making a box plot. So the first thing I need to do is I need to find my 5-number summary. I need my minimum, which is 20. I need to find my maximum, which is 44. I need to find the median. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 4, 4, and there's number 9. All right, median is 35. Now I need to find the median on the lower side. 21 plus 25 is 46. Divided by 2 is 23. And on the upper side, I've got 40 and 42, which is 82. Divided by 2, and I've got 41. All right, I've got 23 for quartile 1, and I've got 41 for quartile 3. Now the 5-number summary is something that we've worked on in prior lessons. All we're doing now is using it to make a box plot. So I'm going to come over here to 35, and I'm going to draw a line. And I'm going to go over to 41, and I'm going to draw a line. And I'm going to go over to 23 and draw a line. And now I'm going to connect my box together. Then I need to come out to my minimum, 20, put a little dot and connect it in, and go out to my maximum, 44, put a dot, and connect it in. And now I have a box and whisker, or a box plot. And here's one that is generated by the computer. It's so much more pretty than what I made, but it's not a competition. I'm not competing with the computer. Now, why do you think it might be important to have a standard way to make a box plot? A way that we agree this is how we'll make a box plot. Well, it's important to have a standard way to make a box plot because it guarantees that everyone will have the same plot when given the same set of data. One of the things that we like in math is that when we look at something and we're asked to do something with it, we'll all do it the same way. Meaning, I give you a set of data and say, would you construct a box plot? We'd like everyone to have the same box plot. We'd like to have that common communication. Now, what does a box plot tell you about the story of the data? And what does it not tell you? And we'll look at this, and then I'm going to back up a slide, and we'll take a look at the box plot. Well, a box plot divides the data into 4 parts. Each part will have about 1/4 or 25% of the data values. The box part of the box plot shows where the middle 50% of the data values are. We have the middle half of the data inside the box. Now, something that a box plot doesn't show, that a dot plot or a line plot does, what are the specific data values? A box plot summarizes the data for us. It doesn't show us all of the little teeny tiny details. So what percent of the data are in each of the sections of the box plot? And how do you know? We answered that question up above. Each section is about 25%, is about 1/4 of the data, because the median and quartiles divide the data into 4 sections that have the same number of data values. And if we back up here, looking at this box plot, inside of this box is about half of our data. We've got from here to about here. About half of our data is there inside the center. Outside of that, we have the other half of the data. So when we look at a box plot, we get an idea of what's happening with the middle half. We can see how close together the middle half is, or we can see how spread out the middle half is, which is the interquartile range. How spread out is the data in the middle half? How close together is the data in the middle half? One thing I can't see looking at the box and whisker plot, I can't see all of these individual numbers. I know that half of the numbers will be in here, but I don't know exactly what those numbers are. I know that I'll have 1/4 of the numbers on each of the end, but I can't see exactly what those numbers are. All right, jump ahead here to the next few exercises. All right, so exercises 8 through 11, those would be in-class exercises, so we can't really do them in a video. And what we do is we actually construct a box and whisker plot with the students in our class. It'd be kind of fun, but we're not meeting that way. So, what are some things you learned about box plots? Well, 1/4 of the data are in each of the sections of the plot. This is a really big concept. When we look at a box plot, we've got 4 sections. And in each section we have 1/4 of the data, about. So we can look and we can see kind of how spread out each section is. If I've got a box plot that looks like this, I can see that this section is very spread out, and I can see that by comparison, these 3 sections are not very spread out. So we can look at it visually and draw some conclusions. The length of the interval for a section does not indicate either how many values are in the interval. So if I look and I've got this really long interval and these really short intervals, that does not mean that I have more values in the really long section. Each of them is about 1/4. So, we make a box plot by doing the following. Using things that we've learned from our other lessons, we're going to find the median, prior lesson. Finding quartile 1, prior lesson. Finding quartile 3, prior lesson. Drawing a number line, been doing those for years. Drawing the box that goes from quartile 1 to quartile 3, new thing today. Drawing in the vertical line for the median, that was a new thing today. Connecting the minimum value and the maximum value to the box, that was a new thing today. The hard work, the median and the quartiles, prior lesson. We just added a little bit more information today. So hopefully as we conclude this lesson, you feel pretty good about constructing a box plot from a given set of data. So take a look at your problem sets, take a look at your exercises. If you've got questions, make sure you ask.